Okay, so we are doing module essentially 3.3, which is finding the real and rational roots, zeros roots of polynomials. So remember we talked before that there are three kind of interchangeable terms that you need to know. One is zeros, the other is roots. Those are both another word for solutions to a polynomial. So you will hear those words interchangeably. A lot of times I'll just say the roots, the solutions, the zeros. You need to understand that all three of those things mean the same thing. Okay, so remember that rational numbers are numbers that can be expressed in the form AB. They can be expressed as a ratio, where A and B are integers and B does not equal 0 because we know we can't divide by 0. That gives us an undefined answer. We haven't talked about imaginary or complex zeros yet, but we will. And right now we're only dealing with real and rational zeros. So what you're learning today is about the rational zero theorem. And what this really helps you do is kind of whittle down all of your possibilities of what your solutions could be. Because when you get a nice long polynomial, you have many, many, many possibilities. This helps you get down to the possibilities that are actually roots, so you can eliminate all of the ones that are not roots. So in this big long polynomial, it's basically saying that your the constant, okay, so this is your constant, is your p, and the q value, they use p and q for this. The p value essentially means the constant divided by all of your leading coefficient. Sorry, let me explain that a little better. Start over. The p value stands for all the factors of the constant in relation to all the factors of the leading coefficient. I told you before that the leading coefficient gives us a lot of information, and this is the first case where you're going to see that. Okay? So, your last term is the constant. In this scenario here, they call that a sub 0, and an is your first term there. Okay? You're only going to use rational zero theorem when the polynomial function is not factorable. If it's factorable, say we have something like x squared plus 4x plus 3, we know that that's factorable to x plus 1 and x plus 3. We would take the inverse of those, the opposite, and those would be our solutions. Those would be 2 points that we could graph on the x-axis to solve. The only time when that's not usable, when something's not factorable, then we're going to go ahead and want to use rational root theorem. Okay, so to find the rational roots of a polynomial, you're going to simply list out all of your possibilities, the factors of the constant term, the factors of the leading coefficient, and then we're going to use synthetic division to find out if it really is a 0. From doing our synthetic practice in class, you know that it is only a solution when that remainder only happens if the remainder is 0. Okay, that's what we're looking for. So let's go down to find all the possible rational roots. We're not actually testing these to see if they actually are zeros. We're just going to write them down. So this is what I'd like to do. So all of our p values are all the factors of our constant, which in this case is 4. So, and you have to include positive and negative factors. Okay? So the easiest way we're going to do this is plus or minus 4, plus or minus 2, and plus or minus 1. So the factors of 4 are 4, 2, and 1. We're going to do the same thing with q. The only factors of 3 are 3 and 1. So when I'm finding all of my possible roots, right, all possible, and again, we're not testing these in this case, we're just writing down all of our possibles. The way I do it is I take one of my denominators, so in this case I'll use 3 first, and make sure that I have all of my p-values divided by that q value. So first I would have 4/3, plus or minus 2/3, and plus or minus 1/3. Sometimes all of your possible roots are going to repeat. You'll see that in later practice. Then you do it again with your other denominator. So then we have plus or minus 4 over 1, which is 4, plus or minus 2, and plus or minus 1. So these are all of your possible roots. So you're going to see why. Look at all the possible roots we have of that. So 2, 4, 6, 8, 10. There's 12 possibilities for that equation. Wouldn't it be nice if we had a method to whittle that down to our actual roots, because we know in that equation we're only going to have 3 solutions. So we can get that whittled from 12 down to 3, life will become much easier, especially for us to graph. That's the real reason that we want to find solutions. So we have a solution to the problem we're being asked, plus we can graphically demonstrate what's going on in that problem. So go ahead on 1B, do the same thing, come back and check your answer. Please disregard that period that's right here in front of the -6. So list out all of your factors of 6, divide them by all of your factors of 4, and write your possibilities off to the right. Go do that on your own, and then come back and check your work. Okay, so all of the p-values that I get are all the factors of 6, which would be plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. Now, for the denominator, I looked for my q values are all of my factors of 4, which would be plus or minus 4, plus or minus 2, and plus or minus 1. So now to find all my possibles, I'm going to start with my first q value, which is 4. So I have 6 over 4, plus or minus 6 over 4, which reduces to 3 over 2, plus or minus 3 over 4, plus or minus 2 over 4, which reduces to 1/2, and plus or minus 1 over 4. Okay? Repeat that same process with your 2's. You have 6 over 2, which reduces to 3, 3 over 2, which we already had here, so we don't need to repeat that again. Okay? We don't need to repeat that one. We already had that from the first set. 2 over 2, which reduces to 1, and 1 over 2, which is 1/2, which we already had here. So again, we don't need to repeat that. Now in the last set, it's all of your p-values just divided by 1. So 6 over 1 is just 6. 3 over 1 we already have here, so we're not going to repeat that again. 2 over 1, so plus or minus 2, and then 1 over 1, which we already have here. So all these are all of our possible values. Okay? On the next page, we're going to use actual rational root theorem, and you're going to apply that to your synthetic division to find possible roots. Okay, so once you've made a list of all of your possible roots, now we're going to find out which ones actually are. Listing all the possibilities of what could be, and then finding out what actually is. So once you finding the rational zeros of a polynomial, and you're only going to do this again if it's unfactorable. Factoring is always your easiest route. If you can't do that, then you come to option 2. So you're going to list all of your possible zeros. That's what we just did on the front page. Then one at a time, you're going to divide those using synthetic division. This is where you're going to see how quick synthetic division can help you move through these. When the remainder is 0, you have found one of the solutions. I would strongly suggest highlighting that in your notes. When the remainder is 0, you have found one of your solutions or roots. The opposite of this number will be your divisor. So for example, if you find that 3, if you plug in 3 in your synthetic division and it has a remainder of 0, then you will have x minus 3 as one of your factor. Remember that solutions are the opposite of factors. If you don't have that in your head yet, you should, okay? And that's because we're setting this equal to 0 and solving. The only thing that can get us back to x, which would be x plus 0, equals 3. So it's always the opposite of what you see here, okay? All right, so then you're going to keep repeating that step until you reach an answer that's quadratic or that you can factor. If you can't factor it, you can use quadratic formula to find the remaining zeros. So we're going to start with number 1. You're going to keep going until you've got all of your roots. And you should remember too, if we have a second degree polynomial, then we have 2 solutions, whether they're real, rational, whatever they are. The degree of the polynomial is equal to the number of roots, which could be rational, irrational, real, or imaginary. Okay? Real, sorry about that. Imaginary, rational, or irrational. Those are all possibilities, but this is going to help us find the actual real whole number roots. Okay, so let's start with number 2. So again, write down all your possibilities of P over Q. You have plus or minus 8, plus or minus 4, plus or minus 2, plus or minus 1. And you have, for that, you just have plus or minus 1. So that makes all of our possibilities really easy. They're just plus or minus 8, 4, 2, and 1. And it doesn't really matter which one you want to start with first. You need to move through all of these until you find at least one of your solutions. So using synthetic division, I tend to kind of start on the smaller end. It's really just a guess. I'm going to start with a 2 and see if actually I'll start with 1. Let's start with 1 and see what happens. So we're going to list all of our coefficients all the way across. I have 1, negative 2, negative 8. And you're going to go ahead and do your synthetic division. So 1 times 1 is 1, negative 2 plus 1 is negative 1, 1 times negative 1 is negative 1, that gives us negative 9. So 1 is not a possibility. If you wanted to list them out across, you could do that, but you can see right here, so this is not going to be 1. Let's use something different for that. Let's use a no, okay, that's not a solution. Let's use negative 1. So we have 1, negative 2, negative 8 again. Pull that down. Negative 1 times 1 is negative 1. Negative 2 plus negative 1 is negative 3. Negative 1 plus negative 3 is negative 1 times negative 3 is 3. Negative 8 plus 3 is negative 5. This is also not 1. So we've eliminated 1s. Those are not possible. Let's try 2. 1, negative 2, negative 8 still goes across the top. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. That gives us negative 8. So 2 is not a possibility. Let's try negative 2. 1, negative 2, negative 8. 1 times negative 2 is negative 2. Negative 2 plus negative 2 is negative 4. Negative 4 times negative 2 is 8. Negative 8 plus 8 is 0. Right here, I've got a remainder of 0. This is a solution. Okay? That's what you're looking for. You want a remainder of 0. Okay? So negative 2 becomes one of our solutions. So we can actually write down here that x plus 2, the opposite of our solution, is going to be one of our solutions. Now rewriting our equation here, we have x. We always reduce our exponent by 1, so this would be x minus 4. So our other factor is going to be x minus 4. I actually gave you one that was factorable, despite my rule that I told you before, to kind of get you to work through the process and see what that was. So those would be the factors of that equation. Those would be the factors. The opposite would be our solutions. So x equals negative 2 and x equals 4 would be our roots that we would graph on the x-axis. This is what's coming on Wednesday. So just a bit of a preview. Okay. All right, so let's go ahead and do another one together on number 3. You'll notice in your book that there are charts for doing rational root theorem and testing a bunch of zeros all at once. I find those charts to be fairly confusing. And even though this seems like a lengthy process to redo synthetic over and over, I do think it's simpler than the charts. You can try the charts if you'd like, or if you find another method to do a lot of synthetic division quicker, please tell me. I haven't seemed to find one yet. So let's go listing all of our factors of the constant in number 3. So that's 6. So we have plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1. Factors of our leading coefficient would be plus or minus 2 and plus or minus 1. So all of our possibilities would be plus or minus 3, plus or minus 6. Then moving over here, plus or minus 3 halves, plus or minus 3 we already have taken care of, plus or minus 2 over 2, so plus or minus 1, plus or minus 2 over 1, which is 2, plus or minus 1/2, and plus or minus 1 over 1, which we've already taken care of here. So these are all of our possibilities. Now it's just time to start plugging them into synthetic division and trying them. So I'm going to go ahead and start with a 3. And my coefficients are listed in descending order, and they're all accounted for. So I have 2, 1, negative 13, and 6. Pull that 2 down. We have 2 times 3 is 6. 6 plus 1 is 7. 7 times 3 is 21. Negative 13 plus 21 is 8. 8 times 3 is 24. That gives us a remainder of 30. So that's not going to be 1. Let me just double check my math on that, because I did that pretty quick. 3 times 2 is 6. 1 plus 6 is 7. 7 times 3 is 21. That gives me 8. 24. Okay, so that's good. So this is not going to be a solution. I'm going to go ahead and try negative 3. So I've still got 2, 1, negative 13, and 6. And so start rocking and rolling. So negative 3 times 2 is negative 6. 1 minus 6 is negative 5. Negative 3 times negative 5 is 15. Negative 13 plus 15 is 2. Negative 3 times 2 is negative 6. Oh, gives me a remainder of 0. So x plus 3 is going to be one of my factors. Now I need to rewrite this equation, dropping one of my exponents, and I will have 2x squared minus 5x plus 2. So now I can check to see, is this something that's factorable? So using BFDs or x factor, that's what I would use here. And I think that that is going to be factorable, because if I pull this across, 2 times 2 is 4. This is negative. If I did negative 1 times negative 4, that would give me 4. Negative 1 plus negative 4 would give me negative 5. So this is factorable. So now at this point, you're going to factor this equation. So I'm going to use BFDs. If you'd like to use x factor, that's fine. I can go ahead and do both for you if you'd want. So 2x squared minus 5x plus 2. I pull that across. X squared minus 5x plus 4. I get x minus 4 and x minus 1. Whatever I borrowed, I need to give back, so I'm going to divide out the 2. I get x minus 2. And then whatever doesn't divide down to a whole number, you swing out to the front. So my other factor is going to be 2x minus 1. So the actual factoring of that polynomial would be x plus 3, x minus 2, and 2x minus 1. If I wanted to find the solutions of these, when you have this situation going on up here, go back to this. Before I found the actual simplified fraction, simplified factor, the opposite of this number is going to be one of our solutions. So our solutions, these are our factors. Our solutions would be opposite of all of these. So x equals 3, x equals negative 3, opposite of this, negative 3, x equals 2, and x equals the opposite of what this was, 1/2. Okay, so there's our factors, there's our solutions for that problem. Okay. So I've got 3 more of those for you to practice. It would be preferable if you went and practiced those on your own, came back to check your work. So I'll give you some time to do that now, and I'll have my synthetic division that I did to get the correct answers. Okay, so going on to number 4. Nice when you have a leading coefficient of 1, because basically all of your factors are going to be only the factors of that constant. So my PQ possibilities are plus or minus 10, plus or minus 5, plus or minus 2, plus or minus 1. There's really not a good way to choose which one of these you're going to start with. I tend to pick kind of in the middle. I think there's a little bit of, I know that I've got kind of a big number in here, so 1's probably not going to be a factor, although it could be once a bigger one is factored out. But I'm going to try, in this case, I'm going to try 2, see what happens. So I have all of my coefficients listed in descending order. They're all accounted for. Sorry, my exponents. Keep misspeaking on that. All of my exponents listed in descending order, and they're all accounted for 4, 3, 2, 1, 0. So I'm good to go on the synthetic division. My coefficients are 1, -5, -5, 23, and 10. Put down. So 2 times 1 is 2. -5 plus 2 is -3. 2 times -3 is -6. -5, -6 is -11. 2 times -11 is -22. 23 minus 22 is 1. 2 times 1 is 2, so that gives me 12. So this is not a possibility. I'm going to go ahead and try -2, see what happens. I get 1, -5, 23, and 10. And same procedure. So I've got -2 times 1 is -2. Add those together, I get -7. -2 and -7 is 14. 14 minus 5 is 9. -2 times 9 is 18. 23 plus 18, -18. That'll help. 23 minus 18 is 5. 5 times -2 is -10. That gives me a remainder of 0. So one of my solutions is x equals -2, which means one of my factors is x plus 2. Okay? If I rewrite my polynomial here, I do one less, so I've got x cubed minus 7x plus 9x, 7x squared plus 9x plus 5. Now I've got to start that process over again but now I've got a new p, q possibilities, okay? They happen to override what was over here, which is fine, but now this is my constant, so now I have to go with only the possibilities of 5. So I'm going to go ahead and try 5 and see what happens. So remember now that you have a new synthetic going on, because now you've got a new polynomial going on. So now you've got to go from this one and use synthetic to factor it. So I'm going to try 5 on the outside, but my new coefficients now are 1, -7, 9, and 5. Bring that down. So these coefficients here are coming from our new polynomial that was left over after we divided out x plus 2 from the original. Okay? So 1 times 5 is 5. -7 plus 5 is -2. 5 times -2 is -10. 9 minus 10 is -1. 5 times -1 is -5. So that gives us a quotient of 0. So x minus 5 is another one of our factors. Okay? And then if I wrote my answer here, now I'm decreasing by 1 exponent again, so I get x squared minus 2x minus 1. Unfortunately, that polynomial is not factorable. So the only way I can solve a quadratic equation that is not factorable is to use quadratic formula, which obviously I do not have enough room on this paper for that. So let me get a piece of scratch paper and we can work. And thanks to the lovely Hannah Sue and her donation of binder paper for her math teacher today. So now we're going to start from this point right here. I hope you've watched the quadratic formula review. If not, you might want to hit pause on this video and go to the other video and watch the quadratic formula review. We did review it in class. So now for this one, I've got to do quadratic formula right here, the x squared minus 2x minus 1. So that's what I'm going to do right here. So our quadratic formula, again, remember, is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay? If you do not remember at this point how to do this, hit pause on this video, go to the quadratic video link on my YouTube or on the Algebra 2 page and get refreshed on this before you do it, okay? List your A, B, and C values. A is 1, B is -2, C is -1. We're going to find the discriminant first, so our B value squared is -2 squared, which is 4, minus 4, A times C is 1 times -1 is -1. So we've got 4 plus 4, which equals 8. That goes underneath our radical, but that can be reduced to 2 square roots of 8. Square root of 4 times square root of 2 is square root of 8. Square root of 4 reduces to 2. Sorry, 2 square roots of 2, not 2 square roots of 8. It's getting late in the afternoon, children, so. Okay, so we're going to put that behind our plus minus sign for our quadratic equation. Now we take the opposite of our B value, which would be 2. We double our A value, which would also be 2. You must reduce all of these coefficients. 2 can go into all 3 of these. All 3, if they can be reduced by the same factor, by a common factor, you must do that. So that's going to reduce to 1 plus or minus the square root of 2 over 1. We can just leave it like that. So our last 2 remaining solutions are irrational solutions, but they are solutions. And these are numbers that you could find on a calculator to find an actual point to plot. And so those are going to be our remaining 2 will be x equals plus or minus, x equals 1 plus or minus the square root of 2. Our solutions here would be x equals -2 and x equals 5. So you've got 1, 2, 3, 4 solutions. This was a 4th degree polynomial, so that's correct. Okay. So these are our solutions. These would be the points that we will plot. You're going to want to bring these notes with you next Wednesday and Thursday also, because it's very likely that these are the points that these are the polynomials that we're going to graph when we start getting into graphing. Okay? All right, go do the ones on page, the numbers 5 and 6, and then come back and check. And I will do them now, so you can check them in a moment. Okay, so number 5. So my possible roots are plus or minus 4, plus or minus 2, plus or minus 1. Yay for not many possibilities, right? So let's go ahead and start with, I'll start with 4 this time, why not? Now, the problem is I do not have all of my exponents accounted for. I have 3, I don't have a 2, so I need to add in 0x squared. So I have 3, 0, -6, and 4. Make sure with synthetic division that all exponents have a space. Be really sure of that before you go through all the work of rational root theorem, okay? So 4 times 3 is 12. 12 plus 0 is 12. 12 times 4 is 48. You can kind of see at this point that that's not going to work out, probably. 48 minus 6 is 42. That's going to be 164, so clearly way too big. So solution of 4 is not a possibility. Okay, let's try -4, 3, 0, -6, 4. Bring that down. 3 times -4 is -12. -12. -4 times -12 is 48. 48 minus 6 is 42. That gives us -164. I'm sorry, -168. Both of these. (168). So that would be 172 up there. Still isn't a remainder. It isn't a remainder of 0, so it's okay. And -168, so that's -164. So we can eliminate 4s as our possibility. Let's try 2, 3, 0, -6, and 4. 2 times 3 is 6. 0 plus 6 is 6. 6 times 2 is 12. 12 minus 6 is 6. 6 times 2 is 12. That gives us a remainder of 16. So 2 is not a solution. try negative 2. We have 3, 0, negative 6, 4. Bring that down. 3 times negative 2 is negative 6. Bring that down. Negative 2 times negative 6 is 12. 12 minus 6 is 6. 6 times negative 2 is negative 12. That gives us negative 8. Still not a possibility. Let's try ones. Maybe I should have started with the ones, you think? So, let's try 1. 3, 0, negative 6, and 4. Okay, 3 times 1 is 3. That adds up to 3. 3 times 1 is 3. Negative 6 plus 3 is 3. 3 times 1 is 3. That gives us a total of 7. So 1's not it. We hope negative 1 is it. We're running out of possibilities here. 3, 0, negative 6, and 4. Pull that down. 3 times negative 1 is negative 3. That gives you negative 3. Why are none of my possibilities working? What have I done? I've done something funky. Oh! I hope one of you noticed what I did the entire way through. What did I do? My coefficient of this first one is not a 3, it's a 1. And yet I put 3 as my first number every time. Those of you who are yelling at the screen right now, good for you. So, let's go back. Let's start number 5 over again. Okay? Flip it over. My mistake. Sorry. 4 o'clock on a Friday. Sorry about that. Okay, so P of x equals x cubed. Why didn't any of you tell me? I couldn't hear you through the computer screen. Come on now. Minus 6 plus 6x plus 4. So let's start again. All of my possibilities are plus or minus 4, plus or minus 2, plus or minus 1. My coefficients are 1, 0, negative 6, 4. That'll make a big difference, don't you think? Okay, so let's try the 4s again. Bring that down. 1 times 4 is 4. 0 plus 4 is 4. 4 times 4 is 16. 16 minus 6 is 10. 4 times 10 is 40. It's going to give us 44. Too much. Negative 4. 1, 0, negative 6, 4. Pull it down. 1. 4, negative 4. 0 minus 4 is negative 4. Negative 4 times 4 is negative 4 times negative 4 is 16. 16 minus 6 is 10. 10 times negative 4 is negative 40. Gives us negative 36. So our 4s are out. Okay. Let's try 2. 1, 0, negative 6, and 4. 1 times 2 is 2. That adds up to 2. 2 times 2 is 4. Negative 6 plus 4. Oh, I have a good feeling about this one. Negative 6 plus 4 is negative 2. 2 times negative 2 is negative 4. Oh! Thank goodness. So one of our solutions is going to be, let's just put him down here, x equals 2, which is a factor of x minus 2. These are our factors. These are our solutions. Okay. So now I have to write my remaining, this started as an x cubed, right back up here, so my answer here needs to start as an x squared plus 2x minus 2. Also not factorable, so now I must use quadratic formula to solve that. Okay, let's do that down here. So I've got x squared plus 2x minus 2, a value of 1, b value of 2, c value of negative 2. Find your discriminant first. Find your discriminant first. So my b value squared is 4. Minus 4 times ac is negative 2. So 4 plus 8 equals 12. That's 4 times 3. Square root both of those because that square root of 12 is going underneath the discriminant. So that reduces to 2 square roots of 3. Plus minus. The opposite of our b value is negative 2. Double of our a value is 2. So your solution, last two solutions are irrational again, but again, points we could find on a graph. And they would be negative 1, dividing all three of these factors by 2, negative 1 plus or minus the square root of 3. So our other two solutions are x equals negative 1 plus or minus the square root of 3. I have 1, 2, 3 solutions, and this is a third degree polynomial, so that's as many solutions as I should have. Okay. All right, last one, number 6. Aren't you glad? I am. Okay. All of our possibilities for rational roots are going to be all the factors of 18 divided by all the factors of 1, which are obviously just 1. So if P over Q equals plus or minus 18, plus or minus 9, plus or minus 6, plus or minus 3, plus or minus 2, and plus or minus 1. Another way to do factors is you start at the ends 18 times 1, 9 times 2, 6 times 3. Those are all the factors. I have no more to evaluate. So let's see. Why don't we start with a 3 and see if that works out. That would be nice. All of my exponents are in descending order and accounted for. 4, 3, 2, 1, 0. Let's write the correct coefficients down this time so we don't have a repeat of number 5. Okay, 1. So let's just double check that. 1, yes, negative 5, 1, 21, and negative 18. Good. So, okay, so 3 times 1 is 3. Negative 5 plus 3 is negative 2. 3 times negative 2 is negative 6. 1 minus 6 is negative 5. 3 times negative 5 is negative 15. 21 minus 5 is 6. Oh, children, look what happened. 3 times 6 is 18. We lucked out on the first one. Oh, I hope if you were doing that on your own, you lucked out on the first one too. That feels good. So, our first factor that we found is the opposite of our first solution. So our first solution is going to be x equals 3, and our factor of that is x minus 3. We're going to write our new polynomial. So since it began as an x to the 4th, our resulting answer out of that, once we divide out, is going to be x to the 3rd minus 2x squared minus 5x plus 6. Now you're going to start with your new synthetic because you have a new polynomial. Okay? So all of our new possibilities, they're still the possibilities of the old one. They still are in this category. But now you can eliminate your two big ones, right? We know it's not 18, we know it's not 9, because now all of our possibilities are only the divisors of 6. So they're only plus or minus 6, 3, 2, and 1. Okay? We've already used up a 3. Now it could show up again because you can have the same, you can have two of the same solution, which I will show you why that occurs on Monday and Tuesday. But now let's pick another one. I don't know. Let's pick a 2. Let's see if that works. It's kind of nice middle of the road. Let's see if that works. So 2. Now our new coefficients are, they're still in descending order, but they are 1, negative 2, negative 5, and 6. Okay, so let's see if that works. So 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. Negative 5. That's not going to work because that's going to give us a remainder of negative 4. So 2's out. Let's try negative 2. Using the same coefficients across. 1, negative 2, negative 5, and 6. Okay. Negative 2 and negative times 1 is negative 2. That gives us negative 4. Negative 2 times negative 4 is 8. 8 minus 5 is 3. 3 times negative 2 is negative 6. Oh, that is glorious. Look at that. So one of our other factors is the opposite of this, would be x plus 2. And our solution is exactly what you see, which is x equals negative 2. So far, so good. Now we need to write our new term, and now we have got 3 terms, which means we're back in the trinomial area. So we have reduced our exponent by 1 from what we had over here. So we have x squared minus 4x plus 3. Thank goodness that is a factorable equation. Factors of 3 are 3 and 1. Negative 3 times negative 1 gives us positive 3. It also adds up to negative 4. So those are our remaining factors, x minus 3 and x minus 1, which means the solutions would be the opposite. which would be x equals 3 and x equals 1. Now, some of you are looking and going, but wait, we already did negative 3. In polynomials, it is very possible to have the same solution show up twice. Okay? In fact, when we were doing our perfect squares trinomials, you'll see that if we had something like this, okay, that factors to x plus 5 times x plus 5, or we can write that x plus 5 squared. On Monday, we're going to introduce an idea, and with the graphing, called multiplicity. That essentially means that we have a term that's happening more than once. Okay? Multiplicity. And it just means that, yes, there are multiples of that answer. So you still can graph with it, but it has a very specific behavior that we will talk about on Wednesday and Thursday. So, happy weekend. Have a good weekend. That's it for rational root theorem. See you on Monday and Tuesday. Thanks.